Alright, this is going to be a video about my Lambda set. I've added a fair bit to this, not in terms of number of Lambdas, but in terms of functionality, mostly. So I last made one of these maybe a year ago, I can't remember, but I have mixed thoughts about sharing this because it's, I will share it, so I'll put a link in the description, but it's essentially like my style of doing things. And these Lambdas are really kind of additional formulas to Excel. So there's so many tricks with Excel formulas as they are, like knowing whether it will take arrays or not, and how you can combine them with other formulas to do nice little shortcuts. And Lambdas are exactly the same as that, so I can combine some of these Lambdas with other functions to do some nice shortcuts, or they have nuances within themselves that allow me to do more things with them when you understand how they work. So just taking someone's Lambdas is not always the best policy. It's always good to build them yourself. And I've definitely taken inspiration from many people to help build these, but all of them I've written myself and tried to understand what's going on under the hood. So anyway, I'm just going to go down them in order. So they're sort of arranged somewhat logically. So the way I've set this file up is I have the name of the Lambda, a description of what it does, mostly to remind myself if it's something I don't use very often. And then I have the formula in here. And the reason for that is if I ever mess anything up in my name manager, like accidentally delete something, then I still have it here to add it back. So let's just go through in order. So arrows just gives me a list of all of the arrow directions. So in many cases arrows come up and I can kind of make a mapping from this to XLOOKUP into based on value of arrow, or I can use this in other Lambdas. And that's another thing I haven't mentioned. A lot of these Lambdas kind of feed each other. This is a set that works together. So a lot of the formulas will have other Lambdas within them that are in this set. So I also have an optional argument on this because I found that sometimes I actually want to know what the row move and column move is. So I've got that on. Sometimes the question might ask, you know, what's the net horizontal and vertical movement? I can do it with this. There's also other ways I can do it, but this is one way to do it. So it's just nice to have. Next up, I have card details. So if I say equals card details, it will just spell out all the cards, their color, suit, the value, and the suit symbol. So that's quite useful. And then I have poker hand. Now I've never actually used this, I just kind of made it in case. But essentially it takes in a 5-card array. So if I say poker hand of these 5 cards, it will just, 1, 2, 3, yeah, it will just tell me what it is. So that's a straight flush. If I was to, let's copy this as values. If I was to put an 8 here, that would no longer be a straight flush, it's just a high card. And let's replace it with a different spade, and now it will be a flush, and so on and so on. So that's, like I said, I haven't used that, but it would be nice to use it because it's kind of cool. Alphabet, I use this all the time, so equals alphabet, it just spells the alphabet. So this is good when there's like certain values assigned to letters or otherwise. Then dice converts things to dice, so let me just show you a dice case. So let's go to this collect them all. So dice, what it does is it just replaces dice with their numbers. So let's import my Lambdas into this file. So if I say equals dice of this, it's just going to change all of the dice in that formula, but leave everything else intact. So if I add some text in here randomly that said like hello or something, it will keep it in there, it only replaces the dice. Then I have another argument on it, which is add. So if I say add, it will add up all the dice in this and ignore other characters. And if I say join, then it will join them in a string. The purpose of that join argument is essentially just to get rid of all the other junk and keep the dice there. So that's really useful. So if I just said dice of all of this, then obviously it will replace them. But if I put add, it will only give me the sum of all the pips, and then I could sum that whole thing up additionally. So for example, and if I just spilled the entire case into here, I'd just get the sum of all of the pips of the dice. Might need to times that by 1 or something. There we go. And obviously I can also then say equals text split this on the delimiter and say dice of that. And that's going to give me all the dices out. I could then check if they're pairs or whatever, or I could just choose to sum them, for example, and then I have all of the rolls like so. Okay, next up is case questions. So if I just type equals case questions, this will give me all of the details out in here. Now it's a little clunky, I don't really like this Lambda because it's pulling out this game board. It's just saying if there's a number here, then give me all of the details here. And give me an NA. It's basically doing a trim range under there, so it's stopping at the last entry. So if I didn't have that table there, it would only give me the questions. And then the reason I've got I've purposely spelled NAs for anything blank is so when I to-call it, they will go away. And when I do my most of lambda, which I mean I'll get to in a minute, it won't have the errors in there. And that actually is the next lambda, most of. So this is just essentially a frequency table. So if I say, I could have text there or whatever else I like. So most of this, it's going to spill out what the elements of the array are and how many are in there. And I can also spill that to anything 2D. So if I put a 2 here, 2 will become the most common thing. And come to the top of the list. So it's always sorted by what's there most frequently. So I use this a lot, often with an at in front of it, because that will just instantly give me the first element. So it's i.e. what appears most often in an array. That's the answer to a lot of bonus questions. So in combination with that case questions thing, I don't necessarily have a good example, but I could say equals most of case questions, and it will tell me that, okay, red appears most often in the case questions, then it's this scarf appears 9 times. So a lot of bonus questions are what is the most common whatever in the question. So I can instantly answer a bonus by just typing at most of case questions, and I get kind of the answer. And there's even a good example for it here. There's one city that has more scarves than any other. Which is it? At most of all of these cities. So yeah, that's a super useful one. Then I have biggest. So this is a new one, and I really like it. So if I just spell the alphabet, for example, and I say equals rand array 26 rows. So if I say equals biggest, I have a range and text or anything else I want to return. And if I just press enter, it's going to give me the biggest item there. So F has the largest number. I also have an optional argument for smallest. So that's going to give me the smallest. At this point in time, it's N. Obviously, these numbers are constantly changing. I do wonder what would happen if there's a draw, actually. It will just give me an error. Let's just do that. I think it will actually just give me the first one in the list, almost like an XLOOKUP. But that's fine. And then I have an optional N. So I could say I want the 5th smallest. Then I have an option called N for what number. So I want the 2nd smallest instead of the 1st smallest. So A is actually the 2nd smallest number here. And I can also say sequence there to give it an array, and it will give me the smallest 2, or if I remove this option, it'll give me the biggest 2, and so on. So it's a bit like an XLOOKUP. So underneath, all that's doing is a sort, and then taking the first or sequence of whatever. Okay, extract numbers. This is really useful. If I have some text with some numbers in it, and I say extract numbers, this it's going to give me the numbers extracted. So it's basically going to allow, it doesn't work on arrays because I've got an array of arrays issue, but it's going to allow for negatives, and if I put a dot in here, it's going to separate by anything else. So it will also allow for a plus sign, I think. Plus 64, okay, it just comes out normal, so that's fine. So one thing I might want to do with this is to allow decimals. So I have an option here to say with decimals. So if I turn that on, now it will treat the dot as a decimal point, so I get minus 39.272 here. So yeah, underneath that it's just a regex function. I forgot to mention, so interjection, I'll edit this back into the most of bit. If I say most of on a single cell, it will actually break down everything in that individual cell. So there's the space appears 7 times, there's 4 A's, and so on. Split text is a very common one, so that is just, I can split an item down, equals split text. I should have named this something else, but it's used in so many other lambdas now, it's too late to change it because you have text split and split text. It's a bit confusing, but all it does is split things into letters. And I can choose groups. I want it in groups of 2, and I can choose overlap. So yeah, it will overlap every 2. So that's super useful and used in so many of my other lambdas. Shift text. So this is for ciphers, and I feel like this is a very overpowered lambda. So let's pull up a cipher case to just show this off. So essentially what this does is it will shift letters around the alphabet by a certain number of points. So I can say shift text this letter this many places. It's actually minus that because we're deciphering. So yeah, this is super useful. So it has a few arguments. So it will work on letters, text. it will work on, so this whole thing is like that there's capitals, so it's supposed to be difficult, but obviously this accounts for capitals by default. So that's like a standard shift, and then I have a long shift. So this has come up in two cases now, this one and whodunit. So the along shift is basically, this is saying, oh, there's an along shift of 1. So I can say the along shift is also minus that. So essentially every letter here is moving by 1 place, but the next one's then moving by 2, then 3, then 4, and in this one by multiples of 2, and so on. I don't know if that's a Caesar shift or whatever. Then in this one, sometimes the along shift is applied to space characters, and sometimes it's not. So I've got a long shift on letters only argument, so it won't shift on the spaces, and it will only shift on the letters. And that is a whole case just done there. That's, you know, insanely overpowered. And then the final argument is no wraparound. So instead of having just the alphabet, it will go into the Unicode characters with no wraparound. So I can solve this case in the time you just have seen there, and I can solve whodunit in the time you've just seen there, basically. So that's really useful. Sometimes the along shift is applied to position 1 and sometimes it's not. So to change, if there's just an along shift, I can just change my normal shift to be offset by 1 or 0, and it will still work. So I have the flexibility to kind of solve what I want there. Now I have word maker. So on Wabble, you have points values for each letter, and you need to make words up with tiles. So the last question is essentially, what words can you make with these tiles? So if I just copy that over to here, word maker will take, I need to import my lambdas, that's going to be a common thing that happens. Word maker, here's the words to make, this works on arrays, the tiles are there, and it will tell me whether I can make the word or not. So I can then just say, for example, filter this whole amount for where that is true. And this then tells me all the words I can make with those tiles. So let's just zoom in a bit so you can see that. I also have a case sensitivity argument if you can only use, you know, capitals or lowercase. So that's that. The way this is working is it's basically saying substitute, this is the text, and the old text is going to be the first letter of this. The new text is going to be nothing, and the instance number is going to be 1. So basically I work through this in a reduce, and I replace only the first instance of an A, then the first instance of a B, and so on, and I reduce and then compare the lengths. If the length I removed from my tiles is the length of the word, then it means I can make that word. And I've made everything work on arrays, so I can, you know, and I'll show you why that is in a second on another one. So word value, I showed this off in my last walkthrough video. So it basically, well, I'll just solve this case with these basically. So I want to know what the value is of these letters. So I can say word value of this letter, and these are the letters, these are the points. So it will take a word, a list of those words, and it doesn't have to be words, it could be anything, right? It could be a list of whatever I want. It's like an XLOOKUP, and a list of values. So it will tell me what the values that is, but the good thing is it works on words as well like this, so I'm able to find the value of those words. The reason these are coming up as blanks is because those words don't actually exist in my list, so they need to be zeros. It's just a nuance of this case. So if I just expand this last question even further, the real question is how many points is the maximum word worth that you can make here. So I can say word maker for this one, for example, and then here's all my words, and my tiles are here. So that's going to give me a list of falses or trues, so I can then say filter all of the words where that. So these are all the words I can make, then I can get the word value of them, and this is the reason I made these work on arrays. So now I say word value of all those words, and my points are here. And then I just want the maximum value, so the best word I can make. So that is, so I haven't actually locked something there, but yeah, that's those two lambdas, so they're super useful. And then if you watch my last video, you'll see that I've also added the ability, so if I just put hello there again, let's say these were not numbers, so I could say equals hash and that. I could say equals word value of this, here's my letters, here's my values, and I can say join instead of sum them. So then now these are not numbers, I can actually see what they're coming out as, so all the letters, and I could choose whatever my delimiter is. So my delimiter could be blank. So again, this is another good one for Cipher type text cases. Next we have count occurrence. So this is just count occurrence of, so how many times does, I don't know, an A appear in this? So 5 times. I have a case sensitivity argument, so how many times does a capital appear? 0 times. Capital A is in there 0 times. Remove characters. Now I've never actually used this one, but when you want to remove a character from a string, you'll say like substitute A for nothing. What if I wanted to remove A and B? Well, I'd have to like substitute it once for the A for blank and substitute again B for blank. So I just have remove characters, text to remove from here, and instead of removing a literal AB, it will remove every instance of A and every instance of B. Now the reason I have that is because if we ever have to clean data and it's full of like a character you need to remove, or 3 characters you need to remove or whatever, I can use that instead of the like find and replace for blanks, and I retain my original data intact without doing the find and replace. Okay, reverse is quite simple. So if I do sequence of 2, 5, I can say equals reverse. If I just do one element of it now, it will put that in reverse. I could also reverse the full array, so it will reverse both horizontally and vertically. I can also do bicol this array reverse. You'll see this won't work because of the limitations of bicol, but another lambda we'll come to in a minute is bicol. So now it's reversed by column, so only horizontally or vertically. So this just allows me to like rotate, flip, do a lot of things to grids that are really useful. One thing I forgot to mention about reverse is it will also work on strings as well. So I like my lambdas, I like to have as few lambdas as possible, so reverse will reverse arrays or strings. If I needed to reverse only strings but within an array, then I would say map reverse, so it does it cell by cell. I guess maybe there's an example I could show with that. So if I had it as an array, it's going to reverse that array, but that's not what I want to do. Instead of the bicol or row version of what I just showed you, I could say map this and then reverse, and because these are now individual cells, it will reverse the strings instead of the array. So hopefully that makes sense. TLOOKUP is just an index match. I don't think I even need to show that one. It's just a 2D, index match. VStacks, this is very useful. So 1, 2, 3, 4. If I want to stack that on top of each other a bunch of times, I can say VStacks this 10 times. So I will get that repeated 10 times. I also have an option for doing it HStack instead, so it stacks it across instead of down. I didn't want 2 lambdas for that just because I want to have as few lambdas as possible. Exists is basically just an isNumber X match. So if I say equals exists 1 in this list, it's going to say true, there is a 1 there, but is there a 5? No, there's not, it's false. I also have search mode, so let's just do like 54. So I can say, move that there. So 5 is still not there, but a 5 exists kind of within one of the cells. So if I was looking for text, I would turn search mode on, which is a 1 here, and that will tell me, it will spill the whole array and show me, okay, true, there is an instance of 5 here. So that's that. Board game move is just a mod with a, so if I say equals board game move, I can say my move value is 6, but my end space is 5. So if I was to move around this board and move to the 6th space, I will recycle back up to 1. If you do this with a mod, it will give you a 0 instead of a 1, so it just eliminates that problem with the mod formula. Array shift, I kind of stole this one from dim, but I made it in my own way. So if I do equals sequence of 5, 6, for example, I can say equals array shift. Here's my array, and then everything is optional, right? So I can shift it by 1 row, and it will move all the rows down 1, or I can shift it by -1 row, and it will shift it up. I can also move it by a column. So if I do 5 columns, actually there's only about 5 columns there, so let's do 3. So shifted everything up by 1 row and across by 3 columns. I also have an option for the fill, so the fill could be Z instead, or anything I like, another formula, whatever. So it just changes that X to a fill. And then instead of that, I can have wraparound turned on. So wraparound now wraps the grid around. So to show this a bit more simply, maybe I just put 1 row and no columns. So you'll see, you know, it's this, but this is wrapped around to be on top as we've shifted that array. Consecutives, so this will tell me where, if I have like 1, 1, 2, 3, 4, 4, 4, and so on, I can say equals consecutives of this, and it will say, okay, there's one instance, then there's a second instance of the same character, but then it's something else. I mean, maybe I could do letters instead, AA. This also works in arrays across, and again, this also works on text. If I had 1, 1, 2, 3, 4, 4, 4, 4, 4, 5, 6, 7, if I said equals consecutives of this, it will spell it out like so. So that's really useful. Long addition, this is like the simple case thing, so I'm probably not going to explain this fully, but I take 2 numbers that are too big for Excel to compute. Do I just open the simple case and show you? There's probably no point. If you're watching this video, you already do lambdas. It's basically all of the simple case stuff. So long addition, I have a first number, a second number, and then I have option to multiply and option to subtract. So again, I've put it all into one lambda because I don't want to have a lambda for long multiplication, a lambda for long addition, and so on and so on. Combinations, this is stolen straight from Bo. So if I have A, B, C, D, I can say combinations of all of this stuff, and I want to choose 2 of them. So it will give me all the possible combinations of picking 2 things from this list. I think Bo's version just gives you numbers. You do it with numbers. I've amended it to just be off of things, because if I wanted numbers, I mean, I could just change those to numbers. So this is just saves me a bit of time. I can say remove duplicates, remove order, sorry. So now AB will appear, but BA will not appear. Allow repeat items allows 2 A's, even though it only appears once here. And then cumulative will give me all combinations from nothing to 1 of something to 2 of something, and then I could say to 3 of something, you know, or whatever it might be. So if I had 3 things, it just gives me all the combinations. Row num and column number give me the row number of a cell, so A57. Instead of doing like row of indirect, I can just say row num of this is 57, col num of this is 1, and I can also do it in an array, so let's say ZF21, so let's change that to be an array, and this to be an array. So here's the row number, here's the column number, and I also have it so it's able to work on, so this is another one, RC ref converter, so row column references, 1,000,000 for the row, and you know, individual units for the columns. So if I put that in there, it still works off of those. So that's nice. Address of cells, if I say equals address of cells, I can highlight anywhere in a grid and it'll tell me what all of the addresses are for those things. So that's mostly, I don't really use that one, I use it within other lambdas to do stuff. Flatten, this is useful for flattening a map, so let's just pull up a map case. God, there's got a lot of lambdas to go through here. So if I pull up the classic Bear Island, here's my map. I can say flatten, let's import my lambdas. I might actually show off some of the other lambdas in this file. Equals flatten this, and it will tell me everything that's in the cells and what cell they're in, and just eliminate any blanks. So I'm able to see where everything is in a map, like so. So then I can do XLOOKUPs to find like what cells items are in, or filters instead of anything else. Find in map, so this is quite useful. So I could say find in map, this is my map, and then I can choose an item. So I've got that bear. So it'll tell me all of those bears are in these cells on the map. And it also takes arrays. So if I do that and I say find in map those things, it will tell me all the addresses where those two things exist. So sometimes where we have map cases where we're traveling to a banana and back, my other lambda, map lambdas, I then say, instead of finding the banana manually, I'll just say find in map banana, this map. It will show me all the places where it is, and then the way my map lambdas work is if I have multiple start locations or multiple end locations, it will give me the distance to, the minimum distance to all of them, basically. Or if they were all targets, it would give me a, I don't know, maybe I'll show you. If I say maze, I'll come to this one in a minute, but here's a map. Start on E27, and then I can say my targets are find in map this map again, and this bear. So if I do that, it's going to say out of bounds, sorry, because I haven't said what I'm allowed to walk on the map. That's another argument. So the allow map is this, let's just say not equal to A, because then I can go everywhere. So now I have the distance from E27 to all the bears with minimum work. Okay, distance, this is actually a really cool one. So distance between two cells, so A6 to, I don't know, let's say F10. So I can say equals distance between, from a start and an end. So it always has those arguments. So it's 5 cells from A6 to F10. And this assumes diagonal movement. But I could have things like, I could change the weighting of a horizontal, vertical, and diagonal element. So if I just wanted horizontal and vertical on, I could say they're 1, 1, and now it's actually 9 cells. If moving horizontally was worth 2, it would become 14. And I can say what the diagonal's worth. So if the diagonal was worth 1.4, for example, that would be like a Pythagorean distance. Say the diagonal's worth say the diagonal's worth 1, but the horizontal and vertical are worth 3, it will change the distance again. So a better example of this would be something like deep sea diving, because we had a non-scaled map where like the distances from the boat to treasure were 3 for moving across, 4 for moving up, and 5 for moving down. So if I get to one of the harder questions, how many meters are the following locations from the boat? Well, I can say distance. Let's import my lambdas again. I knew that I was gonna miss that so many times. Equals distance. Start, I think, is AI2 for the boat. We're going here. Well, horizontal's worth 3, vertical's worth 4, and diagonal's worth 5 in this case. So actually, it might be the other way around, 4 and 3 on the vertical and the horizontal. And then it will tell me the distance for like non-scaled maps. So I really like that method of doing it. I think I stole that from Lorenzo, or at least the idea. And then I've also added a Pythagorean argument. So instead of all this, I can just say I want the Pythagorean distance, which would be different, or I can say the night move distance. So yeah, that's a very flexible one. Then we have move on map. Now this is a really complicated one, but essentially arrow maps. It will allow me to move around, bounce off walls, glide, and so on and so on. I have a whole video on that, so just watch that video, I would say. Closest on map, this is really useful, so I can say equals closest on map. Here's my map. Let's say I start in E27, again, E27, and my steps is, let's say 10. It's going to show me everything I can reach within 10 steps on this map. And I can turn on to say, oh, we can't move diagonally. I can also look for specific items. So if I wanted to look for this tree here, I could say I only want to look for trees. And I can change the order of preference where I go. So this is always in order from lowest distance to highest, but these are all the same distance away, right? They're all 10 away. So sometimes there's preference on whether you will go to a lower row or column first. So I have an option at the end to say I want it in row, column, descending, column, row, descending. So if I change that to like 6, that would be column, row, descending, and ascending. It will change that G19 to actually be the least preferred tree that I go to. So I use that one all the time as well. Block out map will block out obstacles. So it takes, some things and then how much they block you out by, and then I can say equals block out map, this map with these things. I've shown this before, so it will show me, let's just format that, it will show me the range that those blockers can see in. Again, I have a whole video on this lambda and my maze lambdas, so if I put that down to, or up to 5, you'll see these bears now take up a load of space, and I can use this in combination with my maze map to determine where we can reach. So I could say maze, and I don't actually need to do anything. I can keep my maze as the blocked out map and give it a start cell, so E27, and let's not even put any targets in a minute, and it will show me everywhere I can reach. So it's actually, I can just get up to these places. All the blanks are obviously where it's blocked out. So that's that. It also will do stuff like that they can see, well, I can put a fill, so I could put an X instead, like that, because in my maze lambda I can choose to allow or disallow certain elements of the map. So I can use this to spill a certain character and then say in my maze map, you're not allowed to move on X's, so it's easier to avoid things. It just gives me flexibility. No diagonals is also, now they can only see, you know, horizontally and vertical type distance. So if I put that down to 1, that to 2, and that to 4, for example, you'll see it like that. And custom directions is, I can choose whatever directions I like in a row column format. So if I say RC, and this is going to be a good example of how all the lambdas work together, so RC converter of my arrows, that's going to convert all my arrows into RC type references, and let's say I do 2 times that. So now they can only see in jumps of 2. If I said my custom directions were this, for example, let's scale these down a bit. So you'll see this can see 2 spaces away. So it allows like ultimate flexibility really. I could put this down to 1, and let's just do my... So now there's like a weird direction where they can actually see everything down, but then everything else they can only see in jumps, in like gaps, which is obviously random and that's probably never going to come up, but I can essentially do whatever I like in terms of where they can see or not. Okay, next up we have maze. So I've kind of shown this off already, so it's just a maze solver. So I can say maze, actually I have a whole tab for this to explain what it does. I've put the little apostrophes here so that when I open OA Robot it doesn't load all these lambdas and slow things down. So this is just a maze, and I can basically say a list of targets. I can say whether their diagonals are allowed or not, where we're able to move on the map, and custom directions. So that's really flexible. I've got a whole video on it, so I won't show that off too much. And then maze distance, I have a whole video on this one with tree climber, so this is even more crazy and flexible. It's where there's variable distances for every cell in the map, and so on. Priority movement, I haven't shown this, but essentially it takes in a list of a map, again, a start cell, priority arrows, blockers, and how many steps we have. So I'm saying if we run into any of these things, we can no longer travel in the preferred direction. So the preferred direction is down, otherwise it's left, otherwise it's right. So if I started in this cell, my preferred direction is down, but there's a tree in the way, which is one of my blockers, so I can't go that way. So I'll try the next arrow. Okay, it's right, and at this point I'm allowed to go down now. So my preference arrow kicks in, then right, then down, then right, and that's the end. And it spills the path that I would walk and what's in the cells of the path. So I mean, if I turned off trees, for example, so now I've turned off trees, my path is actually going to be like this. This is going to be blocked, so I'm going to go here, then I'm going to go down, and then I'm going to get stuck again, and I'm going to go right, and I'm going to end up in this cell. So that's J17. So here I end in J17, and at that point we stop and we're out of bounds. I can also say allow loops. So in this instance, now I'll get to J17 and I'm blocked, so my next preference direction is right, so I'd go right and I would just bounce left and right along here. So that's what you can see there, it's just bouncing. RC ref convert, I've kind of already shown that off, so I can convert, well, let's just show off a bit more. A1, if I say equals RC ref convert of that A1, it will convert it to its RC references. and I can do it the other way. So RC ref convert of that will just swap it back, and it will also work on arrows. So equals RC ref converter of arrows. I mean, it will take arrays as well. So let's just show you on this whole array. We'll take that whole thing and convert it to RC references, and if it's already an RC reference, it will convert it back to a cell address. Obviously, I can't convert arrows, RC references back to arrows. It would convert this back to an address, but that's fine. Address to contents is a non-volatile indirect. So if I had, I don't know, let's pick N6, so N6, and I could say address to contents equals address to contents of that cell in this map. It will give me the tree, and if I said N7, I think there's a tree in there as well, this will take arrays. And also, if I do RC ref convert of this and paste it over there, that will obviously flip them. It still works on RC refs as well. So it's all of these lambdas will work on any type of like reference for a cell, basically, RC or non-RC. Okay, spiral just creates spirals. So if I had sequence of 3, 3, and I said equals spiral of this, then it's going to take it round like this instead. So maybe a bigger grid would be better to show that one off. So it spirals round, and I can do it in reverse. I just stole this straight from Bo. So now the spiral goes round to the outside like that. And this, in combination with like my reverse lambda, means I can do any kind of spiral orientation, you know, and with the shift array lambda, I can move grids around however I kind of want. By row and by col are basically whenever by row and by column are on arrays, it allows it to work. So I think most people have seen that one. And then primes is literally just a list of prime numbers. I think the first 1,000 primes or whatever I could fit into a lambda, basically. The reason I had that in is because it doesn't come up very often, but sometimes a question says, oh, if it's a prime number, then you do something else. So I can say something like exists 5 in primes, and it will tell me, okay, 5 is a prime number, I don't know, 4 is not a prime number, and so on. So I can just, you know, manipulate if there's any prime number rules in a question for whatever reason. And that is it. So that's a very quick overview, but hopefully it gives people some ideas. There's so much more you can do with these lambdas that I haven't shown. Obviously it gets really complicated, like a lot of them will take arrays or single values, and you can manipulate how you use them by using the map formula and so on. So it's quite a good set. Obviously there'll be more I add over time, but I want to keep it as compact as possible and only necessary things that I want to have. So yeah, hope you enjoyed. A file is down below if you want to use it.